OK. So now we're going to design the thing we just said. So to draw the picture one more time, there are 3 registers we care about. The stack grows down, which means if you need more space, we're going to allocate space lower down in the stack. And as mentioned before, down here in the code section, we have the code for foo and the code for main. So this is all the same picture as before. So here we go. And just to give you a couple more reminders, addresses increase from the bottom of the diagram to the top of the diagram. These are all things you've seen before. Each row represents 4 bytes, also something you've seen before. So just orienting you in this diagram. OK. So as we saw before, when we are running main, main has a stack frame. The EBP points at the top of the stack frame. The ESP points at the bottom of the stack frame. There is our stack frame. EBP says, here's the top. ESP says, here's the bottom. These 2 boxes store addresses, but I drew them as arrows, but they are really addresses. So this is main stack frame. And also, as we mentioned from before, EIP is going to point at the code in main. So there it is. EIP, the instruction pointer, points at the code in main. This is an address. If you go to that address, you'll find the instructions for main. One thing I should call out that I haven't done so yet is ESP kind of has a second purpose. So you can think of ESP as doing 2 jobs at once. It's multitasking. So in addition to remembering the bottom of the current stack frame, it's also the bottom of the entire stack. And that's something you can go home and think about. The bottom of the current stack frame is also the bottom of the stack. There's nothing below this in the stack. So ESP is also saying this is the bottom of the entire stack. Everything below this is undefined. It's total garbage. I have no idea what the values down here are. They don't matter to me. So what this means is, as we saw from before, if you ever push a value onto the stack, you also need to decrement ESP, force it to point lower on the stack so that you remember the thing that you pushed. And that's something we'll see. If you don't move ESP down, you're writing into the abyss. There's nothing there. It's undefined. So if you write it there, the program will not remember it. You have to move ESP down to remember that value. OK, great. So this is what the stack looks like when we're running main. Everything is good. EBP points at the top, ESP at the bottom, EIP points at the code. Now what we have to do is, as we said from earlier, OK, so here's main again. OK, so I guess I shifted the diagram around a little bit. Sorry about that. OK, so here's main. EBP points at the top, ESP points at the bottom, EIP points at the code for main. And when we call a function, this is what has to happen. Are you ready? This is before, whoosh, this after. OK, so what happens after is EBP and ESP need to move down to create a new stack frame. And this is going to be foo's stack frame. And then EIP is going to point at the code for foo. So this is before, stack frame for main, code for main. This is after. EBP, ESP, they shift down. EIP points at the code for foo. So we need to change all the registers so that things look right. And remember, when we're done, we have to put everything back where it used to be. So here's foo. When we're done, we return. Everything's back where it used to be. That's our goal. That's what we have to design. OK, so the key thing, if you fall asleep for the rest of today, the thing that you really have to know is that when you change the value of a register, you should always save your work as you go. So say I want to change EBP because I want it to point somewhere further down. It's not OK to go to EBP and delete the value that used to be there and overwrite it with a new value. Because if you do that, you're losing work. You can't go back. So anytime you overwrite a register, you're going to put its old value somewhere. You're going to write down what value used to be there so that when you're done, you can put that old value back. It's like saving your work. So when I want to change something, I write down the old value. And then when I'm done, I take the old value and put it back. This is how we ensure that when we return, the original, or all the registers are back in their right place. So that's our goal. So if you don't listen to me for the rest of today, just remember that everything we're doing is in the goal of saving your work as you go. That's the really important thing that we have to see. So we got to save our work as we go. Cannot say it enough times.